When dealing with the absolute value equations, you might get some problems that have an absolute value is equal to another absolute value. So how do you go about solving those? Well, these problems, again, every absolute value problem is going to break into two cases. For these types of problems, like this one, the absolute value of 4x minus 5 is equal to the absolute value of 3x plus 5. In the first case, and this is the one that's usually fairly easy and most students remember to do, because in that case you're going to drop the absolute value bars. You're going to write the original problem without any absolute value bars like they didn't exist, which usually makes people happy because they're like, hey, I didn't want to deal with them anyway, so cool, I don't have to write them. That actually is going to get you one of the possible solutions. So if I go to solve this, I'll subtract 3x from both sides, so I'll get x over here, add 5 to both sides, I'll get 10 over there. That is one of the possible solutions. But now we have to worry about the second case. For the second case, I need to take the opposite of one of these two expressions. And it doesn't matter which one you take the opposite of, it just needs to be one of them. I like to always take the opposite of the second expression. So this first expression I'm going to leave alone, so the 4x minus 5, and then for the second expression I'm going to take its opposite. When you take the opposite of an expression, it effectively changes the sign of every term in that expression. So this ends up being my second case that I need to solve for. So if I solve this, I'll add 3x to both sides, so I get 7x. I'll add 5 to both sides, so I get 0. Dividing both sides by 7, you get x is equal to 0. This ends up generating for me my second case. So then both of these then are going to be possible answers, so I'll pull them into my solution set. Notice that this is not interval notation. I'm using set notation on these, as indicated by the set braces. So your two cases are, the one case, notice there's no absolute value bars once I break them into their cases, because at this point I'm dealing with this distance idea. So my first case is going to be the original expressions, but no absolute value bars. And then for my second case, I'm just going to take the opposite of one of the two expressions. I will always take the opposite of the second one just because I like to be consistent, and that's how I like to handle these problems. And then just go and solve that second case and then pull your two answers together. Now if I take a look then at applying those to this next problem, so you can see this maybe in action one more time. So in the first case, I'm just going to set these two expressions equal to each other. No absolute value bars. And in the second case, I'm going to take the opposite of the second expression. And when I take the opposite of that, I will effectively then, once I distribute that opposite idea through, it'll change the sign of both of those terms. So if I go through and then solve these, in this case if I add x to both sides, I'll get 2x, subtract 2 from both sides, I'll get 2. Which means x equals 1. On this one though, if I try to subtract x from both sides, notice that the variable vanishes, it wipes itself off on both sides, and I'm left with a statement that's mathematically false. So at this point in time on this branch generates for me no solution. Now the entire problem is not no solution, just this one case doesn't work out. So then my final answer to this problem then is going to be the solution that was generated from the other case, which was x was equal to 1. So in this problem I'm not going to have two possible values that make the variable true. I'm only going to have this one value.